Welcome to another Ziva Math video. In this video, we're going to learn about solving equations that have variables on both sides. If you need a review of the basics of solving equations, check out the links in the description below. If you're ready, let's continue to our examples. In this example, we have 4x plus 3 equals x plus 9. So as you can see, I have a variable on both sides of this equation. And even though we have a variable on both sides of the equation, your basic steps and procedure for solving this equation are going to be the same as if you were solving a 1 or 2-step equation. We still want to make sure that whatever we do to the left-hand side of the equation, we do to the right-hand side of the equation because we need to keep it balanced. So if having the line through the equal sign helps you to do that, go ahead and add that line here. Then we want to get our variables all on one side of the equation. Right now I have 4x on one side and x on the other. So I want my variables on one side and then I want my constants on the other. So let's start by worrying about the variable. I have 4x on one side and x on the other, and I need them to be on the same side of the equation. So I'm going to look at the right-hand side. I have just one x there. And if I subtract x from that side, then I won't have a variable on that side anymore. So you notice I'm doing the inverse operation. I had a positive x, so I'm going to subtract that x. If I subtract x from the right-hand side of the equation, I also have to subtract x from the left-hand side of the equation. And you can also work with your constants at the same time. However, if you're just starting out, I suggest working these problems one piece at a time or one step at a time. So I'm on the left-hand side. I have 4x minus x, and 4x minus x is 3x. Then I have 3 plus 0 is 3. And then on the right-hand side, I have x minus x, which is 0x, so I don't even need to show that in my equation anymore. I don't have an x on the right-hand side of my equation. And then I have 9 plus 0 is 9. So now I'm working 3x plus 3 equals 9, which is a two-step equation. I want to get my variable all by itself isolated on the left-hand side of the equation, which means my next step is going to be to subtract 3. If I subtract 3 from the left, I'm going to need to subtract 3 from the right. Notice I'm doing the inverse operation again. And now on the left-hand side, I have the 3x. I didn't do anything to it. I have 3 minus 3, which is 0, so I don't need to show that anymore. I have just 3x on the left. And on the right, I have 9 minus 3, which is 6. Now on the left, I want to get x isolated by itself. I have 3 times x, and the inverse operation of multiplication is division. So I'm going to be dividing by 3. If I divide the left-hand side by 3, I have to divide the right-hand side by 3. 3 divided by 3 on the left is 1, leaving me with just x, and 6 divided by 3 on the right is 2. So my solution is x equals 2. In this example, I have 2n minus 9 equals 7n minus 4. And I'm going to be needing to get my variable on one side of the equation and my constants on the other, keeping in mind that I'm going to be doing inverse operations and that whatever I do to the left-hand side, I'm going to be doing to the right-hand side of my equation because I have to keep my two sides balanced. So the first thing you might want to do is draw the line through the equal sign so you can make sure that whatever you do to the left, you do to the right. And as we just stated, we're going to want the variables on one side, the constants on the other. And I'm going to start with the variable. And I'm either going to need to have my variable on the left-hand side or on the right-hand side. And what you choose to do is really up to you. Some people like to keep the variable on the left. Some people look for the steps that are going to keep the coefficient with the variable a positive. It's entirely up to you. In this example, I'm going to put my variable on the right-hand side because doing that is going to give me a positive coefficient. with that variable, which means on the left-hand side, I don't want to have that 2n anymore, so I'm going to need to subtract it, doing the inverse operation. If I subtract 2n from the left, then I need to subtract 2n from the right. So working left to right, I now have 2n minus 2n, which is 0, and I don't have any n anymore on the left. The variable is now gone, so I'm not even going to show it as 0n. I don't have a variable on the left-hand side anymore. Then I have the negative 9. I didn't do anything to the negative 9, so my negative 9 is still on the left-hand side. Now on the right-hand side, I have 7n minus 2n, which is 5n. And this is why I did this step, is subtracting the 2n on the right-hand side leaves me with a positive coefficient with the n. So it leaves me with 5n. Then I have negative 4 plus 0. I didn't do anything to the negative 4 on this side, so I still have subtracting 4 or the negative 4 on the right-hand side. Now I have a two-step equation. Negative 9 equals 5n minus 4. So my next step is going to be to add 4 to the right-hand side because ultimately I want the variable isolated on the right. So I'll need to also add 4 to the left-hand side of the equation. So negative 9 plus 4 is negative 5. The 5n, I haven't done anything to it. I still have 5n on the right. And then negative 4 plus 4 is 0. And I don't need to show that anymore on the right-hand side. So now I have negative 5 equals 5n. And I want to isolate n, get it all by itself. Right now I have 5 times n. My inverse operation is going to be division. So I'm going to be dividing the right-hand side by 5, which means I need to divide the left-hand side by 5 as well. And on my right-hand side, 5 divided by 5 is 1, which leaves me with n. And on the left-hand side, I have negative 5 divided by 5 is negative 1. So my final solution is n equals negative 1. In this example, I have negative 3m minus 7 equals 5m plus 9. And I have this screen set up so I can show you the steps side by side of some of the different options that you can take at the beginning of these problems to get started. We are going to use the inverse operation because that's what we do when working with equations. And we do need to make sure that whatever we do to the left-hand side, we do the same thing to the right-hand side. So you may want to start with the line through the equal sign so that you can make sure that whatever you do on the left, you do the same thing on the right. And I like to start with the variables and decide what my steps should be based on what coefficients I have with my variables because I need to get the variables either on the left or on the right. So on the problem I have set up on the left, we're going to put the variable on the right-hand side of that equation. And to do that, that means I don't want negative 3m on the left-hand side, so I need to do the inverse operation, which is going to be to add 3m. If I add 3m to the left, I'll need to add 3m to the right. So now on the left-hand side of the equation, I have negative 3m plus 3m is 0, leaving me with just the negative 7 on the left. Then on the right, I have 5m plus 3m is 8m, and I still have the positive 9. So this step moved my variable to the right-hand side, but it left me with a positive coefficient with that variable. So what was your other option? Well, your other option is to put your variable on the left-hand side of the equation, which means that 5m that we have, we want to do the inverse, which is to subtract 5m. If I subtract 5m from the right, I'll need to subtract 5m from the left. Negative 3m minus 5m is negative 8m minus 7 equals 5m minus 5 is 0m plus the 9. So now I have negative 8m minus 7 equals 9. And at this point, your equations that you're going to be solving look a little bit differently, but you'll still get to the same answer. Now, my personal preference is to have the positive coefficient with my variable and have the variable on the right-hand side versus having the variable on the left with the negative coefficient, but that's really just a personal preference. So I'm going to continue solving from here using the option on the left, those steps. So I'm going to solve the negative 7 equals 8m plus 9. Our next step is to, of course, get to where we have our variable completely isolated, which means we need to be subtracting 9. If I subtract 9 from the right, I have to subtract 9 from the left. Negative 7 minus 9 is negative 16. 8m, I haven't done anything else with a variable, so it is still there. And 9 minus 9 is 0, so I have negative 16 equals 8m. And to get m isolated by itself, I am going to need to divide because 8m is 8 times m, and my inverse is division. If I divide the right-hand side by 8, I need to divide the left-hand side by 8. So 8m divided by 8 is m, and negative 16 divided by 8 is negative 2, for a solution of m equals negative 2. In this example, I have 2a minus 2 equals 10 minus 4a. So I have an equation with variables on both sides of the equation, and we are going to use our steps and procedures for solving equations of whatever I do to one side, I have to do the other in order to keep the equation balanced, and using the inverse operations as I work through the steps in this problem. So the first thing that you might want to do if it helps you or if you're new to equations is to draw a line through the equal sign, which will help you make sure that whatever you're doing on the left-hand side, you do the same thing to the right-hand side. And while I would normally encourage you to work everything one step at a time, especially if you're new to solving equations, in this example, I'm going to combine some of the initial steps, which is something you'll likely do as you get more comfortable with these types of problems. So first, I'm going to look at the variables. So I have 2a on the left and negative 4a on the right. And I am going to want to put my variable in this case on the left-hand side because that will not only give me the variable on the left, which is where many of us are more comfortable having it, but it's also going to give me a positive coefficient in front of that variable because on the right-hand side I have negative 4a, and my inverse operation then is to add 4a. If I add 4a to the right-hand side, I have to add 4a to the left-hand side. And doing this is going to give me my variable on the left-hand side, which means that as I work with my constants, I'm going to want my constants to end up on the right-hand side of the equation. If I'm going to be getting those constants to the right-hand side of the equation, that means that this negative 2 that's left here on the left-hand side, I'm going to need to do the inverse operation there. And the inverse operation to subtracting 2 or the negative 2 is to add 2. If I add 2 to the left-hand side, I'm going to want to add 2 to the right-hand side. And this is a step where I said a second ago, you may want to work one at a time. I would take care of the 4a, the adding 4a, then I would do another step where I take care of the constants. But in this case, let's show what you're likely going to move into as you get more comfortable with these problems and work these steps at the same time. So if I start on the left-hand side, I have 2a plus 4a is 6a. I have negative 2 plus 2 is 0. And I'm not going to show that 0, so on the left-hand side, I'll just have the 6a. Then on the right, I have 10 plus 2 is 12. And I have negative 4a plus 4a is 0a. And 0a means I don't have a variable on that side anymore, so now I have 6a equals 12. So I have 6 times a. I want to isolate a by itself, so my inverse operation is to divide, and I'm going to need to divide both sides by 6. So 6a divided by 6 is a, and 12 divided by 6 is 2, for a solution of a equals 2. Thank you for watching. Be sure to like this video and subscribe to Ziva Math for more videos.